So in 1.2, we're going to continue with our transformation. So the same stuff we've been doing in chapter 2, but we're going to be applying those transformations to equations. So it's going to tell us what type of transformation we have to do, and we're going to manipulate the equation that's given to us based on that transformation. So here's a list of our transformations. It's important to know that when we go left or right, so a horizontal translation is inside the parentheses. And then also when we have a reflection across the y-axis, that is inside the parentheses, and everything else is outside. So when we move left or right, it's inside. When we have a reflection across the y-axis, that is inside also. So the first two transformations that this section talks about is horizontal and vertical. So horizontal, we would go left or right. So that is inside the parentheses. Down here it says we subtract h from the inputs. That just tells us that whatever we do, we're applying it inside. Now, remembering what we did in the last couple sections, what happens if I add on the inside? Which direction would I go? Left, perfect. And what about if I subtract on the inside? Right. So don't forget those. And then for our vertical translations, this happens in the output, so outside. If we have parentheses, it would happen outside the parentheses. If I add, which direction am I going? Up. And if I subtract, down. All right, so looking at example 1. 1a. We have to write a function g whose graph is a translation 3 units down from the graph of f. So 3 units down tells me I'm adding or subtracting? Subtracting, and on the inside or outside? On the outside. So we subtract 3 on the outside. So my function is 2x plus 1, and now I am subtracting 3. So I just take the function that it gave me and apply my transformation. Can I simplify? So what's 1 minus 3? Negative 2. And then last thing is that it tells me it's a function g, so I just have to name my function, so I would just say g of x. So you can't just have an expression without an equal sign, you got to put that equals g of x. So most of I think all the homework ones tell you to name it g, but some of the ones in the notes will tell you to name it h. So looking at b, now it says write a function h, whose graph is a translation 2 units to the left. So to move my graph 2 units to the left, would I need to add or subtract? I would add 2 and inside. Now here we don't have parentheses, but when we add 2, we're adding it directly to the x. So this would be 2. I'm adding 2 to the x. It would be x plus 2 plus 1. Now how can I simplify this? Distribute the 2. So this would be 2x plus 4 plus 1. And then the last thing to simplify? Add 4 and 1. So it'd be 2x plus 5. And then last thing I got to do is just name it. It tells me it's a function h, so I would just say h of x. Next transformations we're going to look at are reflections. A reflection in the x-axis, does that happen inside or outside? Outside. X's, you want to keep your x's outside the house. So this is outside. So we would just multiply that to the entire function. So we're multiplying the output, the outside. Now reflection in the y-axis is inside. That just happens directly to the x. to the inside. All right, so let's look at example 2. For part A, I have to write a function g whose graph is a reflection in the x-axis of the graph. So the x-axis is inside or outside? Outside. So I have to multiply my entire function by -1. So I multiply negative to the outside. So it would be negative times the whole function. So times the absolute value of x plus 3 plus 1. So that negative gets distributed to the absolute value part and the plus 1. So this would be negative absolute value of x plus 3. We can't go inside the absolute value, so we just leave it outside there. And then minus 1. So this is g of x. So when it's a reflection on the x-axis, it gets multiplied to the entire function. Now for B, we have to write a function h whose graph is a reflection in the y-axis of the graph. So y-axis is inside. That happens directly to the x. So I got to multiply that negative directly to the x. So it would be the absolute value of negative x plus 3 plus 1. I can't simplify anything here, so this would be my h of x. On the bottom, we have 4 more examples where we're moving it left, right, up and down, and reflections. So for number 1, what happens when I have a translation 5 units up? Adding 5 on the inside or outside? Outside. So that 3x stays the same, and I just add 5 to the outside. So this would be my g of x. Can't simplify anything there, so that's it. All right, for number 2, I have a translation 4 units to the right. How would I show 4 units to the right? Add or subtract? Subtract 4 on the inside. So this just happens inside that absolute value bar. The absolute values kind of act as parentheses. So inside just means it happens inside. So it would be absolute value of x minus 4 inside the absolute value, and that minus 3 just stays outside. All right, for number 3. We have a reflection in the x-axis. So x-axis is inside or outside? Outside. When it's on the outside, I have to multiply it to everything. So it's negative times negative absolute value of x plus 2 minus 1. And I would just have to distribute that to the absolute value part and the number outside. So what's a negative times a negative? It would become positive absolute value of x plus 2. And negative times negative 1 would make it a positive 1. So this is g of x. So when it's a reflection on the outside, it has to get distributed to everything. But we can't touch inside the absolute value, so it just stays outside the absolute value. All right, and then the last one is a reflection in the y-axis. So y-axis is inside or outside? Inside. It happens directly to the x. So it would be 1/2 times negative x plus 1. How could I rewrite this to make it look normal? Wouldn't say 1/2 times negative x. Where should that negative go? Just in front of the 1/2. So it'd be negative 1/2 x plus 1. All right, next, we're going to look at vertical stretches and shrinks. We can ignore the horizontal one for now. So just vertical stretches and shrinks. This gets multiplied to the outside. So I would just multiply it to the entire function. If I have two things inside the function, I would have to distribute it. Bless you. So it says let f of x equal absolute value of x minus 3 minus 5. We have to write a function h whose graph is a vertical stretch of the graph by a factor of 2. So I would have to multiply it by 2, and I multiply it to the outside, but I multiply everything by that 2. So it would be the absolute value of x minus 3 minus 5, but everything gets multiplied by 2. Yeah. So what would I have to do to multiply this by 2? Distribute. What does it get distributed to? Well, it gets distributed to the absolute value part and the 5, but it just stays out front of the absolute value. We can't distribute it inside the absolute value bars. We just leave it out front. So it'd be 2 times the absolute value of x minus 3 minus 10. And that would be my h of x. Okay, let's look at 6 right below it. So I have a vertical shrink by a factor of 1/3. So that 1/3 gets multiplied outside. What would I have to do next? Distribute it. So it gets distributed to the absolute value and to the minus 3. So it'd be 1/3 times the absolute value of x. What's 1/3 times negative 3? So if I had 3 times 1/3, I'd multiply a fraction by a whole number, but just by making the second one a fraction, multiply straight across, it'd be 3 over 3, which is what? 1. So it'd be negative 1. So this is g of x. Any questions there? All right, next page. So here we have a combination of transformations. When we apply multiple transformations, we just have to do one at a time in the stated order. So whatever order it tells us to do it in, we just follow that. And it's important that we only do one at a time. So we apply the first transformation it tells us first, and then the second one. So it says, let the graph of G be a vertical shrink by a factor of 0.25 followed by a translation of 3 units up of the graph. F of x is equal to x. So we're just using x for our starting graph, starting function. How do I apply a vertical shrink by a factor of 0.25? What would I need to do? Multiply it. So it would just be 0.25 times x. And then what about a translation 3 units up? Plus 3 on the inside or outside? Outside. So we just add 3 at the end. So just plus 3. So my function here, g of x, is equal to 0.25x plus 3. All right, we're going to skip 5. We'll come back to it, but let's take a look at 7 at the bottom. So it says, let the graph of G be a translation 6 units down, followed by a reflection in the x-axis of the graph. F of x is equal to the absolute value of x. Write a rule for G. So to apply, what do I apply first? 6 units down. Am I adding or subtracting? I subtract 6 on the inside or outside? Outside. So I would take that absolute value of x and just subtract 6. Next, I have a reflection in the x-axis. How would I show a reflection in the x-axis? Negative on the outside. So that means it gets multiplied to the whole thing. So then what would I need to do? distribute the negative. Does it go inside the absolute value or stay outside? It stays outside. We can't touch inside the absolute value. And then that negative times negative 6 would just turn it into a plus 6. So this is g of x. So for 5, it's just to help us refresh our memories on what type of transformation does what. So what happens when I subtract 4 on the outside? Down 4. What about when I add 4 on the inside? Left 4, perfect. What about when I multiply by a negative on the outside? Reflection on the x-axis. Awesome. Right, now looking at D. What happens when we add 1 on the outside? Up 1. What about when I subtract 1 on the inside? Right 1. And then for F, am I multiplying by a negative inside or outside? Outside. So is it a reflection on the x-axis or y? Reflection on the x.